Hi Lakewood, 7th grade math students. This is Ms. Van Vickle, and this is video 4 for this week. I'm calling this video Proportional Relationships in Tables, Graphs, and Equations. And in this video, I'm going to show you how proportional relationships can play out kind of like, well, not kind of like, exactly like equations of lines. So I'm going to start with an example that I think is pretty intuitive for most students. And it's an equation you really should know, so it's time to get acquainted with it. And it looks like this, where this is distance, and this is rate, and this is time. And we say that distance is equal to rate times time. So that might look a little confusing, but let's look at an example. Excuse me, and I think that it will make sense. So let's pretend for a moment that I'm on the freeway and I'm driving 60 miles per hour. And imagine if I could keep my speed perfectly constant at 60 miles per hour. Well, 60 miles per hour, notice I use the word per. That means that's a rate. And so in our equation, distance equals rate times time, where I would put that 60 would be right here for my rate. And now I have two things that are changing, distance and time. And what I know is the distance I have traveled depends on the amount of time I spent doing it. In other words, if I travel, and I'm just going to make a little t-chart of t values and d values. If I travel for 1 hour, I would substitute a 1 for t, and 60 times 1 is 60. So when I've traveled for 1 hour, I have gone 60 miles. Let's put a few more values in our table. If I travel for 2 hours, most of you would almost immediately say that I should have gone 120 miles. So I can put this value in my table as well. And then I can say, let's get one more value. After 3 hours, well, 3 times 6 is 18, and then I'd add a 0. So I would have gone 180 miles in 3 hours. Now, I want to stop for just a moment. There's one more value I want to put in my table, and that's if I travel for 0 hours. So if I were to put a 0 in for t, I would get a 0 for my distance, because obviously if I travel 0 hours, I can't go any miles. So I'm going to take this equation that I have turned into this table, and I'm going to make a graph of it. So I'm going to draw my Cartesian coordinate plane. Have you heard that word before? The coordinate plane. And my x and y axis, except in this case I'm graphing time on my x-axis, and I'm graphing distance on my y-axis. And I'm going to graph these points that I sorted out. So I know I have a point at 0, 0. And let's just mark time. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. And I'm going to let each one of these notebook lines be 60 miles, because that makes it really super easy to graph. So I've shown you two elements that are essential when you graph. You need to describe what your axes represent, and you also need to describe the scale that you're using, and you need to keep that scale consistent. So if I go 0 miles, or if I go 0 hours, I've traveled 0 miles. If I travel 1 hour, we said that was 60 miles. 2 hours is 120, and 3 would be 180. And I can connect the dots, and I can graph my line. Now, we'll talk in a while about why it doesn't make sense to graph this part of the line. But technically, our equation, or at least mathematically, it would make sense to go ahead and graph this part. Because I really could insert negative numbers and get out negative numbers, even though it doesn't make sense in the context of the problem. So what we notice is we have something called direct variation. And this is super duper important. You need to know this forever and ever and ever. And what direct variation is it's something that will always graph as a line. It will always go through the point 0, 0. And there will always be a rate in it, and that rate will be a unit rate. In our case, in this example, that rate was miles per hour. But I want to do one more problem for you that isn't related to the distance equals rate times time problem. That's just a little bit different. And I think you've seen it in terms of ratio and proportion, but maybe not how I'm going to present it now. So let's say I am baking cookies. The holidays are coming, and that's a popular thing to do. And that I have a recipe that calls for 1 cup of flour for every 3/4 cups of oatmeal. I'm going to make some oatmeal raisin cookies. And so this is my ratio of flour to oatmeal. And we've been used to things like scaling this up. Like if I'm going to bake 2 batches, I would have 2 cups of flour. I'd multiply that times 2, and then I'd have to scale up the oats as well so that it was all in proportion and the cookies ended up tasting right. So I can generally say that if I want my rate, it's 3/4 oats for every 1 cup of flour. And again, I have a rate and I have the word per. Oats per, cups of oats per flour, if that makes any sense. So I'm going to write this like an equation. And what I'm going to say is that X is going to be equal to the cups of flour and Y is going to be equal to my cups of oats. And let's see if that makes sense. Let's make a table of values like we did before. And I'm going to say that I'm going to put X there and Y there because we always do it that way. And I'm going to say, well, if X is a cup of flour and I put in 1 cup of flour, that is 3/4 times 1. So if I have 1 cup of flour, I get out a Y value of 3/4. And that makes sense because that's my basic recipe. But if I decide to scale it up and instead make 2 batches of cookies, now I have 2 cups of flour, and then I'm going to need 6/4 of a cup of flour, and I'd prefer we simplified that to 3/2. Improper fractions are great, but they should always be simplified. And let's see, let's go ahead and figure out how many cups of oats I would need if I used 3 cups of flour. And it looks like that's 9/4. So 3 cups of flour is 9/4 cups of oats. And if you really feel compelled to turn that into a proper fraction, that's 2 1/4 cups. And this would be 1 1/2 cups, right? Just kind of so we have an idea of what we're talking about. And then let's go ahead and scale it up one more time for for quadrupling our batch. We would have 3/4 times 4, which I think gives me 12/4, and that reduces to 3. So if I put in 4 cups of flour, then I need 3 cups of oats. So what I'm intent on doing now is making a graph of these values. Excuse me. So again, I'm going to draw my coordinate plane. And I need to label my axes. This is X, which is flour. And this is Y, which is oats. And I'm going to mark this off in 1 cup, 2 cups, 3 cups, and 4 cups. And then I'll do the same here. 1, 2, 3, 4, 5. This would be cups. That's our unit of measure. We should probably indicate that too. Okay, so now let's graph these points. When I have 1 cup of flour, I have 3/4 of a cup of oats, so that's just below that 1 cup line. When I have 2 cups of flour, I have 1 1/2, which is right about here for my Y value. When I do 3, I have 2 1/4. Let's see, 1, 2 1/4 would be just a little above that line. And then when I have 4 cups of flour, I'm using 3 cups of oats. And that would be right on that line. Oh, and you know what we forgot to do is we forgot to talk about how many cups of oats would I need if I had 0 cups of flour. And of course that's 0, 0. And so if I connect my dots, what I notice is I have, again, a linear equation. Y equals 3/4 x is my equation. So take a look at what we just did. I talked about direct variation or proportional relationships in terms of an equation, right here, a table, right there, and my graph of values. So I hope this video helps, and there will be some classwork on this video that will get you much more accustomed to direct variation. And oh, the other thing we need to talk about is there's another word for that guy, and I'm not sure you know what it is. In fact, there are lots of words for this unit rate here. Unit rate is one of them. Another one that you've probably heard is that's the slope of the line. And another one that you really need to know that is related to direct variation is it's the constant of variation. I'm running out of room here. Constant of variation. So there are 3 different names that we know this 3/4, or in our very first example, that 60 miles per hour was the slope of our line, the unit rate. It was also our constant of variation. So get used to hearing those words talked about. Thanks.